So in the last class, we will discuss here what? We will discuss BGP and BGP features, basic of BGP, and customer types of BGP, and then BGP port number concept, IBGP, EBGP, network and neighbor command, BGP messages, IBGP loop prevention mechanism, EBGP loop prevention mechanism, IBGP next hop, EBGP next hop self command, route reflector, correct? And how to make a reachability using IGP, this is also discussed, correct?
Mm-hmm.
You know, I told you we can make a reachability like next hop IP reachability using the static routing, default routing, IGP protocols, right?
Yes.
And I also told you some features of next hop self command. We can also add the next hop self using the network command, and we can also use the route map, right? Perfect. After that, here we have what BGP state. So this state we will discuss later. Okay, not now. Okay. Yeah. Now what we will discuss. Okay. Like last class, I skipped one point that is important. So first of all, I'll clear you that point. Then we can go in the next, right? Okay. That is a very small point, but yes, in this BGP class, that is a very important point because here we will discuss each and everything in the BGP.
Okay.
So let's take two routers, R1 and then R2. So first I'll make a neighborship in between R1 R2. So R1 having 10.1, R2 having 10.2. Okay, on R1 interface F0 bar 0, 10.1, 255, 255, 250. Say no shut. On R2, 10.2, 255, 255, 250. And then say what? No shut, right? And let's say on R1, I have a loop back that is 1.1.1.1, 255, 255, 255 to 255, correct? Okay. Now on R1, let's go on R1 and then enable the BGP, router BGP say 100, and then say neighbor. The neighbor is what? 192.160.10.2, and the remote AS will be what? That is 100 again. And on R2 as well, exactly same. Router BGP say 100, and the neighbor is what? 10.1. Remote AS will be what? 100. Wait for a second. The neighborship is up. It will take some time. Yeah, the neighborship is up, right? Now what I want to share this prefix. You know, on R1 router, do shape interface brief. On R1 router, we have a route, we have a loopback, and I want to share this loopback. Then what command we are using here? Tell me.
The network command, right?
Perfect. We are using a network command to share this prefix. So I'll say network 1.1.1.0 mask 255.255.255.0. Correct?
So that will be the whole network, right? In that case, that you are sharing.
What?
Yeah, that'll be the full network sharing.
Exactly, you're sharing the whole
Yeah,
network.
I want to share this route. I want to share this loopback IP. That's why I'm using this network command like this, right?
Exactly.
But now if I'll show you the BGP table, do show IP BGP, say enter. So they don't show me this route in the routing table. Why?
Because
they don't show me this route in the BGP table.
Because it's a classful. I don't know.
Yes, actually what happened right now, I'll configure this IP 1.1.1.1/32, right? So this is the mandatory part here, like when we are using a network command, right? So always use the same, exactly same. It means same IP and same subnet mask, right?
Okay.
So yes. So just to say no this command,
So that
Okay,
means
and
it's a
then say
class
what
4.
network 1.1.1.1 exact match.
Okay.
We need to do exact match. In case of IGP protocol like RIP, IGRP, OSPF, if you are configure like this, so yes, they will accept that command, no problem, and they will work. But in case of BGP, if you are using a network command and you want to share the route, so remember this thing. First of all, you need to check the loopback IP address and the subnet mask. Exactly same. You need to enter here the network command. Correct?
Okay. Got it.
Yeah, that's it. Now, if I'll show do share BGP, so yes, it will share
There you
this
go.
prefix, right? Yeah.
Okay.
Okay.
That's it.
Yeah, that's what I thought. That's why I asked you if it is the whole network that you were when you put the command.
Yes, yes, yes. Actually, yeah, when I put this command like 1.1.1.0 mask 255.255.255.0, so that is the whole network,
The
right?
whole network.
And I want to
Yeah.
share only one prefix. Yes. Okay, so that is superb. Everything is going good here. Now let's discuss here what. Stay
Can I
tuned.
ask a question? What
Discuss.
was the command for the route reflector that I couldn't write it down?
What is the command? What can you repeat again?
What is the command for the route reflector or the RR? I remember it was neighbor, the
Route
IP,
reflector.
but I forgot. Yes.
Yeah. Wait, give me a second. I'll show the command. The command is what router BGP say 100, and then say neighbor command. Let's say you want to add this route reflector at your neighbor for a neighbor 10.2, right?
Mm-hmm.
So just
Yeah.
to say route reflector client.
Okay.
Okay, route. Okay, then you get to choose if it's a client, it's a server, or non-client.
Yes. And one more thing, you are entering this command in a server device. Okay, you are entering this command on server device, server router. Okay, just to say go on server. Let's say this is your server device. So just to say my neighbor 10.2 is what? Client, right?
Okay.
That's it.
Okay.
Yeah. Okay. Perfect. Now let's discuss here neighborship types in the BGP, right? So if I'll talk about the neighborship types, so in case of IBGP, we have 3 types of neighborship. In case of EBGP, we have 3 types of neighborship, right? So the first is what that is? What?
The
IBGP,
fastest one?
direct neighborship, and this and in EBGP, that is what? IBGP direct neighborship, right? Okay.
Okay.
Okay. So first of all, we'll discuss here what IBGP direct neighborship, right? So let's say this is the topology. Let's go on R1 and then say what? No router BGP say 100, and on R2 just to say what? No router BGP say 100. Okay. Now let's go on again on R1. And what is the command? Just to say here what? Router BGP say 100. Neighbor 192.168.10.2 remote AS will be what? 100, right? On R2 I'm saying what? Router BGP say 100. Neighbor 192.168.10.1, and then say remote AS will be what? 100. That's it. So the neighborship is up. It will take some time. Give me a second. Yeah, the neighborship is up. So this is what? This is not normally like we are doing yesterday as well, these things. So this is called what? IBGP direct neighborship, right? So first I can explain here you what? IBGP.
So that's the simplest neighbor connection, basically, no?
Yes. Yeah. So this is what IBGP direct neighborship. And now I can explain you what? EBGP direct neighborship. Just to remove first of all here. Okay, now on R1, just to say what router BGP say 100, and then say neighbor 190.168.10.2, but the remote address will be what? 200. And here also I'm saying what router BGP say 200, and then say neighbor. It is what 10.1, and the remote address will be what?
100 it is.
100. So wait for a second again. It will be show me a log. Give me a second. Yeah, the neighborship is up, right? So this type of neighborship is called what?
eBGP neighborship. So basically, it's the simplest eBGP neighbor, the same as the other one.
Yes.
The
So
only difference is that
So
they have different ASNs, and they
yes,
become external.
yes, correct. This is what in between different ASN, and this is in between same ASN, right? That's great. Perfect. Now I'll explain you what IBGP indirect neighborship using physical interface. IBGP indirect neighborship using physical interface, correct? Okay. Right. So this is the topology. Let's configure the IP address. And on R3, Done, right? IP address is configured. Now, what I'm saying here, see, right now I'm doing which one?
Indirect neighbor. IBGP indirect neighborship.
IBGP indirect neighborship using physical interface. Okay. It means let's go on R1 and then say here what? Router, BGP, and then say 100. And right now on these three routers, I'm using 100. I'm using IBGP, so I'm using a same AS. Okay. And say the neighbor is what? 192.160.20 dot. What? 2.
20 dot. But which one? This is R2 or R1?
Yeah, right now I'm on R1 and I'll
So it
say
says
my neighbor is not 10.2. My neighbor is 20.2.
20.2? How can you do that?
Yeah. Okay. Yes. And
Okay.
and say remote AS will be what?
100, I guess.
100. Okay. Now let's go on R3 and then say what? Router BGP, say 100, and then say the neighbor is what? 10.1. Remote AS will be what?
100.
100. But still
It won't go up.
the neighborship is down.
Yeah, because you have to configure R2. So you want to do it indirectly, connect them.
No, yes, this is actually the indirect neighborship, right? So I'm not configure the BGP right now. I'll configure the BGP on R1 and I'll configure the BGP on R3. I'm not configure this BGP on R2, right?
I thought it was impossible in IBGP. I thought it was only possible in EBGP.
And this is not eBGP. Like we have here also it is 100 AS. Here also it is 100 AS. Here also it is 100 AS, right?
Okay.
So I can make a neighborship in between these two physical interfaces.
Oh, okay.
Okay. So because normally what happening always in IGP protocols, I'll make a neighborship on my front of the interface.
That will be like the direct neighborship, but you can do it indirectly.
Yes, that is we can say the direct. And if I'll make a neighborship with like this, so this is what indirect neighborship, right?
So you can do it both ways, basically.
Yes.
Okay.
But right now the problem is what? I'll configure the command, but still the neighborship is down. Why? Okay. The concern is what? Why the neighborship is down? I'm saying on R1, my neighbor is what? I'm saying neighbor 192.168.20.2. Okay. One requirement is there. If you are creating IBGP neighborship, if you are creating what? IBGP indirect neighborship, then the first requirement is what? Neighbor IP should be available in routing table. Okay. It means right now on R1, I'm saying my neighbor is what? 20.2. So if I'll show you the routing table, in the routing table right now, they don't show me the 20.0 network, correct?
So you need to use an IGP protocol?
Yes, we need to use any IGP protocol or static routing. Okay.
Okay.
So and exactly same on, I'll show you on R3. On R3, if I'll show you, so the neighbor command is what? That is 10.1. It means the 10.0 network. Now I'll show the routing table. Do show IP route. Can you see here? They don't show me any 10.0, right? That's why the neighborship is down. Okay. So what we need to say on R1, I'm saying my neighbor is what? 20.2. So we need to install 20.0 network in the routing table. So you can install this 20.0 network in the routing table using static routing, using any IGP protocol, but we are not using
default. Doesn't work with default route.
We are not using. Okay. Because once we are using a default route, so it didn't work actually here. Okay. I'll show you. So first of all, I'm using what? Static routing, right? So on R1 router, I'm saying here what? In the BGP command, I'm saying my neighbor is 20.2. It means we need to install 20.0 network on R1 router routing table, right? So I'm saying here what? Using the static routing.
Okay, that one is R1. Okay, so you want to do it with R3, the neighborship. Okay, then?
Yes. And now I'm installing the 20.0 network using the static routing, right? 20.0, 255.255.255.0, and I'll say 10.2. Now if I'll show you do show IP route. So yes, this 10.0 routed in 20.0 route is installed in the routing table, right or wrong?
Correct.
Okay, perfect.
So why, let me ask you a question. Why did you add 10.1 instead of the 10.2? On the actual route, yeah, there. See? Oh no, wait, no.
On the static routing.
No, you're correct. No, I made a mistake. It's fine. Okay, now I understand. Okay.
Yeah. So do show IP route. So yes, 20.0 network is installed in the routing table. That is fine. Super. Okay. Now on R2, sorry, on R3, do show on pipe section. Router BGP. On R3, I'm saying my neighbor is what? My neighbor is 10.1. It means we need to install 10.0 network on R3, right or wrong? I'll say IP route 192.168.10.0, 255, 255.255.0, and then say what? 20.1.
21, exactly. You need to do it the other way around.
See, immediately the neighborship is up.
Okay. Yeah, because if you don't do that, the routers cannot see each other, basically.
Yes. So right now, I'm not running any BGP. I'm not running any BGP on R2. But yes, this R1 router make a neighborship with R3.
So wait, you're using iBGP.
And let's say go on R1 router and then say what router BGP. Let's do one thing on R1. First of all, we need to check we have any loopback or not. So right now we don't have any loopback on R1. So first of all, we need to make a loopback on R1. 1.1.1.1, 255, 255, 255.0. And I'm using what router BGP say 100. And I'm using a network command. And I want to share this prefix 255, 255, 255 say 100. Do show IP BGP. Yes, it will be show me this prefix here. Now if I'll show you on R3. So do show IP BGP. So yes, it will be show me this prefix here, right? Without running any BGP on R1. Yes, R3 will show me that route in the BGP table. Clear?
So you can do neighborhood indirect neighborhood ship using this method. Basically, you can do it without configuring the R2. From what you say, you can configure BGP on R1 and R3 indirectly. You can connect them without having to configure the R2.
Yes, without configuring the BGP here. Why I'm doing like this? Because you know I told you in BGP routers we have a lakhs of route, right? We have a lakhs of route in the BGP. So in BGP router, let's say if I'll configure the BGP here, here, and here. So these three routers will maintain these lakhs of route. But if I'm configure the BGP on R1 and on R3 only, then this lakhs of route will receive via R2 and R3 only. This router is not receiving those routes. So that is a good thing actually, right?
Okay.
So this is what? This is called what? iBGP?
iBGP, indirect
neighborship using physical interface.
Good.
And the requirement is what? If you want to, if the neighborship is down, the physical, let's say the iBGP indirect neighborship using physical interface, the neighborship goes down. So what you need to check? You need to check this thing. Neighbor IP should be available in the routing table, right? Done? Okay. Now, exactly same thing here as well. eBGP. Indirect. Neighborship. Using the physical. Using the physical interface, right? Okay, so let's go on R1. And just to first of all remove the BGP here. And on R2. And on R3. Okay, now let's go on R1 and then say what? Router BGP say 100 and then say neighbor. I'll say the neighbor is what? 192.168.20.2 and the remote AS will be what? That is
200. Wait. Yeah,
200. And on R3 I'm saying what? Router BGP say 200 and my neighbor is what? 10.1 and the remote AS will be 100, correct?
Mm-hmm. Yes, correct.
Still the neighborship is down. Why? The same concept. The network should be available in the routing table. So what we need to do? We need to go on R1 and I'm installing the 20.0 network in the routing table IP route.
Okay.
55255.255.0 and then 10.2. Done. And here as well, I'll say what IP route 10.0 255.255.255.0 and the next two pipe will be what? It's 20.1. Done. Now do show IP route. I'll show the route in the routing table. Yes. Can you tell me if the route is available or not? Yes, that route is available. And here also I'll show you the 10.0 route is available. Yes, it is available. But here still the neighborship is down. In IBGP, the neighborship is up, but here the neighborship is down. Why?
Mm.
On which one? On R3?
It means
EBGP.
here also, what happening? In case of EBGP, the requirement is what? The first requirement is exactly same, right?
Mm-hmm. So what's the difference in EBGP?
It means what? The neighbor IP should be available in the routing table. This concept is same in both the case. But still right now the neighborship is not up. Still the neighborship is down. I'll show you. Do show IP, BGP summary. So it will be show me the state will be what? That is idle. Okay. Why it is actually? You know, I told you yesterday class, I told you one point. What? IBGP having TTL value 55. EBGP having TTL value 1. Right? Okay. First of all, explain me what is TTL. Have any idea what is TTL?
Time to leave.
Okay, why we are using this TTL?
To refresh. No, well, it's like checking something, like checking the connection, like every couple of seconds.
Okay, no, not like this. No problem. I can explain.
I'm trying to explain it in a more technical way, but I
yeah, no problem, no problem.
I you know what? I know what it is, but I cannot explain it. So.
Okay, yeah. Sometimes it happens. Okay, so what is TTL? TTL stands for time to leave. Okay. First of all, I'll show you the problem. What is the problem in our network? So let's take an example. We have router R1, R2, and then R3, right? In between R2 and R1, let's say here I'm having 10.1, 10.2, 20.1, 20.2, 30.1, 30.2, right? Okay. And now let's say this R2 router wants to communicate. This R2 router wants to communicate 192.168, 100.100, right? This R2 wants to communicate 100.100, right? So R1 router, R2 router will check. We have any 100.100 IP here on R2 router? No, we don't have. So what this R2 router will do? This R2 router will forward this route to where? To R1, correct? Now R1 will receive this packet 192.168.100.100. So this R1 router is also checking. We have any 100.100 route IP? No, we don't have. Now R2 router, R1 router will send towards R3. R3 router will receive what again? 192.168.100.100. It will be checking. Okay, I have any 100.100 route? No, we don't have. What this R3 router will do? Again, this R3 router will send to R2. Again, this R2 router will send to R1, R2, R2, R1, R3, R2, R1. And again, this is what? Loop.
Wait 1 second.
And this type of loop is called what? This is called layer 3 loop. Because this loop is created by the IP address and on the router device. That's why I'm calling here. This is what layer 3 loop. So this is the problem. This is the problem in our network. So how to resolve? How to resolve this problem? So we can resolve this problem using the TTL. TTL stands for time to leave. Now what's happening? Let's say we have a router R1, R2, and then what? R3. Here we have 10.1. Here we have 10.2, 20.1, 20.2, 30.1, 30.2, correct? Again, this R2 router wants to communicate 192.168.100.100, correct? Okay. Now what this Cisco will do actually? Cisco will say, whenever if we are sending any ping packet, so inside that packet by default, the TTL value will be what? 255. By default, the TTL value is what? 255. Okay. So now if this R2 router will send this packet, so inside the packet, the TTL value is what? 255. Previously, in the previous topology, we don't have any TTL, but nowadays Cisco will add the TTL. Okay. Now R2 router will check. We have any 100.100 IP? No, we don't have. R2 router will send this packet to R1. Correct. Now R1 will receive this packet like this 192.168.100.100 with the TTL. What? Tell me.
255.
255, right? Okay. So actually, what is the rule here? Whenever any router will receive any packet with TTL 255. So what that router will do? Whenever the router will receive any TTL value, so what that router will do? That router will decrement by 1. That is what? 254. 254. Okay. Yes. Now R1 will send this packet, the same packet to R3. So R3 will receive this packet 192.168.100.100 with the TTL is what? 254. So whenever this R3 will receive 254, what it will be doing? It will be decrement by 1. So that is what? 253. Correct? Exactly same. When R2 will receive, so it will be decrement by 1. Why 1? So that is what? 252. Once this R1 router will receive, that is what? 251. So like this, one by one, every hop, one TTL is decrement, right? And after some time, what happening? After some times, what happening actually? This R1 will receive again the same packet 192.168.100.100. Let's say now the TTL value will be what? 1. So once this R1 router will receive this packet with TTL 1. So what it will be doing? -1, that is what? 0. It means what?
Will stop sending.
TTL expire. And whenever the TTL will be expire, so that router don't have power to share this packet to the next router. It means now this router will drop the packet here. It means, you know, once the packet is going like this, circle and circle and circle, so that is what loop. But what happening here, we are adding the concept that is TTL. So once the TTL value will be 0, immediately that router will stop that packet here, right? I hope this is like TTL concept is clear to you guys. Any doubt?
Yes, we got it.
Super. So basically why we are using a TTL? TTL is used to avoid a layer 3 loop actually. Okay. TTL is used what? It is used to avoid the layer 3 loop and every hop decrement by 1. Okay. Whenever the device will doing a ping. So by default inside the ping packet, inside the ICMP packet, by default the TTL value will be what? 255. Okay. That's it. So this is the concept of the TTL. So exactly same thing here. I'm explaining you. In IBGP, we have a TTL what? 255. In EBGP, we have TTL what? 1, correct? Okay. Now what happening in this time? Why the neighborship is not up? Because the requirement is done. That requirement is what? If you want to create IBGP indirect neighborship using a physical interface, then the requirement is what? Neighbor IP should be available in the routing table. So that requirement is completed. See, the neighbor network address, it will be shown in the routing table. Still the neighborship is down because of
TTL.
Why? Can you tell me in EBGP, what is the TTL value?
1.
1. And when this R1 router will share the packet, see, once you are using, okay, on R1 you are using what? Okay, I'll show you on R1 do show pipe section router BGP. Okay. So on R1, I'm using this command neighbor 192.168.20.2, right? It means what this R1 device will do, the device will send the update. Inside the update, what happened? The source IP will be what? 10.1 and the destination IP is what? It's 192.168.20.2. Okay. And inside the packet, this is what EBGP neighborship. That's why the TTL value is what? That is 1. Correct? Now, once this R2 router will receive this packet, so it will be receiving this packet TTL 1 and it will be decremented by 1. So that is what? 0. So it means that packet will drop here always.
Okay.
So R2 router is not able to share this packet to R3. That's why the neighborship is down, right? Okay. And in IBGP, why the neighborship is up? Because the TTL value is what? That is
255.
Okay. So are you getting a point? The problem is what? Why in EBGP the neighborship is not up right now?
Yes, because of the TTL.
So what we need
drops in the
to do?
second.
We need to increase what?
TTL. Okay.
TTL value, right? We need to increase the TTL value. Okay. Perfect. And one more thing is there. Actually, the first problem is what?
TTL expiration.
Right? TTL expire on R2 router. Now the second problem is also there. What? Actually, in EBGP, by default, in EBGP, BGP by default connected check command is enable. What I'm saying here, by default, what happened in eBGP by default, connected check command is enabled. Connected check, it means what? Okay, I can explain you. Guys, on R1, I'm saying my neighbor is what? Tell me.
The R3.
Yes, it means IP address is what?
Yep, 20.2.
Right? Okay. And by default, connected check command is enabled. Connected check, it means this R1 router will find our neighbor, directly connected router. Actually, what happened? By default, this command is enabled. Connected check command is enabled. What happened in this command? Actually, what this R1 router will think, my neighbor is directly connected with me. It means this interface is my neighbor. But actually, you are saying your neighbor is what? This one. But by default, this command is enabled, connected check command. So what this R1 router will think, my neighbor is front of me. What this R1 router will think, my neighbor is front of me. So what we need to do? We need to remove that command. Which one? We need to say, first of all, neighbor.
No neighbor.
192.168.20.2 and then say disable connected check. Because when I'm not disable this command, then what happening? Then always it will be checking the neighbor front of me. But right now my neighbor is not front of me. My neighbor is what? Indirect neighbor, right? So that's why, first of all, we need to disable this command. I'll say what? Neighbor disable connected check, right?
So wait, what do you use this? Why do you use this command for? The disable connected check?
To disable
because
the
what
neighbor
happening? By default, this command is enabled.
Okay.
By default, connected check command is
enable.
So what actually this R1 router will think? R1 router will think my neighbor is front of me, because by default connected check command is enabled.
Always.
So it will be find our neighbor front of the router.
Okay.
So that's why we need to remove this command from here. Because yes, that's why I'm disabled, because my neighbor is not directly connected. My neighbor is what? Indirectly connected, right?
Well, you're disabling the ping on the R3 basically, right?
Yes, on both the router, we need to disable it.
I know. Okay.
Yeah, router BGP, and then say 100. Sorry, it's 200, and then say what? Neighbor 10.1, and then say what? Disable connected check. Done. This command is done, and after that we need to say neighbor 168.20.2, and then say what? eBGP multi-hop. You know, by default the TTL value is what? 1. If I say here 3 TTL value, then it means whenever this R1 router will send the packet, so the TTL value is what? 3. Whenever this R2 router will receive 3 minus 1, that is what? 2. Okay. Then what? Then R2 router will send to R3. It means 2 it will be received. 1 minus 1, so it will be what? 1 here, right? So it means now what we need to say, how to increase the TTL value? The command is what? This is the command. Neighbor 192.168.20.2 eBGP multi-hop 3. Say enter. And here also we need to say the same command. neighbor 192.168 10.1, and then say what? EBGP multi-hop. I'll say multi-hop will be what? 3, correct?
Okay, so wait, the command is IBGP multi-hop?
No, the command is what? This one, neighbor EBGP multi-hop 3.
Okay, so you have to configure it in both routers?
Yes, we need to configure this command on both the router. Yes.
1 second. Let me
So
see.
why EBGP multi-hop 3? Well, why number 3?
Because
Because
of
I'm
hop.
saying the TTL value will be 3.
Why not 4? Why not 5?
Okay. Yeah, you can say the 5 as well, no problem. Okay, let's say I'm setting, okay, let's say on R1, I'm setting the TTL value will be 2, right? So R1 will forward this packet to R2. R2 will receive 2 minus 1. That is what? 1.
Wow.
R1 will send to R3. So it is what? 1 it will be receiving.
Minus
1.
0.
That is what? 0. It means now this router will drop the packet here, but the destination will be here. It means yes, the neighbor should be up. If I'm saying that the TTL will be 2, that is also good. 3, that is also good. 4, 5, 6, 7, 8. No problem. But by default here, the TTL value will be 1. That's why always this R2 router will drop the packet here. If you are saying the
Yeah,
TTL 5,
it will not
10,
forward the
that
packet to
doesn't
the
matter.
next
No problem.
router. Yeah.
Can I see?
Yes.
Can I see the command again?
Yeah, this is the command.
Okay, EBGP. Okay. So this command is only for EBGP.
Yes, because why? See, basically using this command, we are increasing the TTL. And why this command is for EBGP only? Because in IBGP, we have TTL 255. No need to increase that. Okay. In EBGP, by default, the TTL value will be 3. That's why we need to increase this. That's why this command is for the EBGP only, correct?
Okie dokes.
Yes.
Got it.
So let's go on. Again, I'll show you all the commands, like what are the commands that I'm enable here. Router BGP. R1 as well, do show run. Okay, on R3. Okay, so on R1, I'm using both the command like EBGP multi-hop 3 and disable connected check. Now we need to use the same command on R3 as well. So I'll say here what? First of all, I'll say what? Disable connected check.
Check. Okay.
And then we can say what? EBGP multi-hop 3. Wait for a second.
Come on.
Still the neighborship is down. Why? We need to check it. Do show run 5 section router BGP on R1, and on R3 do show run 5 section router BGP. Disable connected check. IP address is correct or not? Yes, IP address is correct. Everything is good. One more thing, we need to check it. The route is available. Yes, that route is available. Here, yes, that route is available. To show IP BGP summary. Please show me idle.
Maybe there's something in the R2 that is blocking it or something?
No. Wait. Standard 2. Okay, can you see here? IP address, read the IP address.
Oh yeah, 169. That was a
Yeah,
mistake.
that is the problem. Now just to say neighbor, 192.168. 10.1 remote address will be what? 100. Disable connected check.
Multi BGP,
EBGP.
multi-hop. Multi-hop.
Multi-hop
Great.
3. See,
There you go.
the neighborship is up now.
Boom.
Okay. So it means if you want to make a what? EBGP indirect neighborship using physical interfaces. So the first requirement is what? Neighbor IP should be
Neighbor.
available in the routing table, right? Second
Mhm.
requirement is what? We
The protected
need
check,
to
the connected check
yes
disabled.
use disable connected check command. In the third requirement, we
You need to
need
increase the
to
TTL value.
yes increase the TTL value.
Mm-hmm.
Done. Super.
Yes.
Okay. So this is what right now what I can explain you: direct neighborship and indirect neighborship. Okay. Perfect. Now the third one I can explain you, that is what? IBGP indirect neighborship using loopback interface. Okay, right? So, okay, now so let's do one thing first. Okay, let's go on R1. On R1, I'm saying what? Do should run 5-section router BGP. Let's disable the BGP here. And on R2 as well. Sorry, R2, I'm not enabling any BGP. On R3, no router BGP 100, and just to say 200 as well. Done. So BGP is not there. Okay. Now let's do one thing. Let's go on R1. And first of all, check we have any loopback or not on R1. So yes, we have a loopback that is 1.1.1.1. And on R3, we have any loopback or not? No, on R3, we don't have any loopback. So we need to create a loopback on R3. I'll say what? 3.3.3.3. 255, 255, 255, 255. Correct? Done? Okay, let's go on R1 and let's go on R3. So on R1, I'm saying what? Router BGP say 100, right? And I'm saying what? My neighbor is what? Neighbor 19. Sorry, the neighbor is what? Now I'm creating a neighborship using the loopback interface IP, right? It means on R3, can you tell me what is the loopback that is? 3.3.3.3, and then say the remote AS is what?
100.
That is 100. Exactly same on R3. I'm saying what? Router BGP say 100. And the neighbor is what? 111 and AS will be what? 100. Clear?
Okay. Yeah.
Done? Okay. So still the neighborship is down. Okay. Why the neighborship is down? Because the first requirement is what? Yes. Perfect. The first requirement is what? That is exactly same.
Exactly. But if you don't create the routes, they're not going to see each other.
Yes. So we need to go here. Okay, it means we need to install this route in the routing table, right? Do show IP route. So right now 111 route is not available in the routing table on R3 router. And if I'll show you an R1, so I'm saying my neighbor is what? 3.3.3.3, and this 333 route is not available in the routing table. So first of all, we need to install this route using the static routing. Okay, and on R3 as well, we need to say same IP route. Done. Now if I'll show you in R1, so it will be show me do show IP route. So yes, 111, sorry, 333 route is available in the routing table now. And if I'll show you an R3, do show IP route. So yes, 111 route is available in the routing table, right or wrong?
Exactly.
Okay, perfect. But still the neighborship is down. See, do show IP, BGP summary. Still the neighborship is what? Idle. Why? Okay.
Because
I'm telling you why. Okay. Okay. On R1, you are saying my neighbor is what? And on R3, you are saying what? My neighbor is what?
1.1.1.
Okay. We need to do one more thing. Need to configure these routes on R2 router as well. Yeah. So what I'm explaining you right now, on R1, I'm saying my neighbor is what? 3.3.3.3. On R3, I'm saying my neighbor is what? 1.1.1.1. Correct? Right? Okay. You are saying my neighbor is this and my neighbor is this. That is fine. But what happening whenever you are entering this? Sorry. Yes. Whenever you are entering the neighbor command, then what happen? What this R1 router will do actually? This R1 router will send the update with the source IP 10.1. Why it will be taking 10.1? Because it will be always taking the exit interface IP as a source IP, correct? So the source IP will be what? That is 10.1, right? This thing is clear? And the destination is what? You are saying my neighbor is what? 3.3.3.3. So the destination IP will be what? 3.3.3.3. This thing is clear to you?
Yeah,
okay, perfect. Exactly same thing. R3 router will also send the same packet. R3 router will send the source IP. The source IP is what?
20.2.
It's 20.2. And the destination IP is what?
1.1.1.
Tell me. What is the neighbor IP?
1.1.1.1.
Yes, that's great. Okay. So the concern is what right now? Okay. R3 router will receive this update, right? Once this R3 router will receive this update, so this R3 router will check this update I can receive from where. So it will be checked. This R3 router will check what? Source IP. The source IP is what?
10.1.
And on R3, I'm saying my neighbor is what? 1.1.1.1. Only I can receive the update 1.1.1.1. What this R3 router will think? My neighbor is 1.1.1.1 and I can receive only the update from my neighbor 1.1.1.1. But right now, this R3, what this R3 router will think? This R3 router will think I can receive the update from which router? 10.1. Getting your point?
Hmm.
And
Okay.
exactly same thing happened here as well. See, R3 router will send the update, so the source IP will be 20.2. And what this R1 router will think? My neighbor is what? 3.3.3.3. It means I can receive the update only 3.3.3.3. And right now this R1 router will receive the update from where? 20.2. So that's why the neighborship is what? Down. Because what this R3 router will think, my neighbor is 111. So only I can receive the route. Only I can accept the update once I receive the update from 11111. Then only I can accept the update. Another, I'm not accepting the update. Exactly same. This R1 router will also thinking, my neighbor is what? 3.3.3.3. So I can receive this update only for 333. If I receive the update from any IP, so I'm not able to receive that update. And right now, this R1 router will receive the update from where? 20.2. So that's why this R1 router not accept this update. That's why neighborship is what? Down. Clear? The problem is clear?
What's the solution? Like add the 10.1?
Yeah, perfect. The solution is what now? Okay. What this R1, R3 router will think? R3 router will think my neighbor is what? What this R3 router will think? I can receive the update only 1.1.1.1, right?
Mm-hmm.
So on R1, I'm using a command, the special command. That command is what? That command is what? I'm saying on R1, what? Neighbor. I'm saying whenever if you are sending any update to my neighbor 3.3.3.3. So what do you need to do? Just to say here, update source loopback 1. What it means? Update source loopback 1. It means using this command, what this R1 router will do? This R1 router will say, whenever if you are sending any update to our neighbor, which one? When you are sending any update to our neighbor 3.3.3.3. So what you need to do? Update source loopback 1. It means just to change the source IP. Just to change the source IP. And what source IP you can put? The loopback 1. What is the loopback IP of R1? That is 1.1.1.1. So after using this command, what happened? This R1 router will remove this exit interface IP from the update source, and it will be putting here what? 1.1.1.1. Done.
Okay.
Okay. And now once this R3 router will receive the update, so this R3 router will check what is the source IP. The source IP will be 111. It means what this R3 router will think, I can receive the update 11111 and my neighbor is also 1111. So yes, I can accept the update, right?
Okay, okay. So
Exactly
basically
same thing.
the command is saying instead of receiving by the i10.1, you receive the update
Yes.
by, it will change
Yes.
the basically.
Yes, exactly. It means using this command, we are changing the source IP basically here. Okay.
Okay.
Yeah. And on R3
But
as well, we need to use this command. On R3, if I'm using the same command, so what this R3 router will do? This R3 router will put here what? 3.3.3.3. Now, once this R1 router will receive the route, so what this R1 router will think, I can receive the update from 3.3.3.3, and my neighbor is also, I'm saying my neighbor is what? 3.3. So it means what this R1 router will think, I can receive the update from my neighbor 3.3.3.3. So yes, this R1 router will accept this update. Clear?
Okay.
Done? Yes.
So what's the
So
command?
remember this
basically?
thing.
Can you show us the command? How to do it?
Yeah. So let's go on R1 and use the same command. Do show run pipe section router BGP. So yes, I'm using this command router BGP 100, and I'm using neighbor 3.3.3.3 remote AS 100 command, right? And then I'm using neighbor 3.3.3.3 update source loopback 1, right? Exactly same command we need to use on R3 as well.
Okay,
Do
so
show
neighbor
run.
did. Okay, so the neighbor. Okay.
Yes.
So that's the command neighbor.
Router BGP. The command is what? Neighbor 1.1.1.1 and then say what? Update source loopback 1.
So this update source command, what does it do?
Basically, this update source loopback command will change the update inside the update source IP.
Inside.
In the packet, basically.
Yeah, inside the packet, yeah.
Okay. All right.
Because normally what happens whenever the device will send the update, so what source IP it will be putting inside the packet, the exit interface IP as a source IP it will be putting always in the packet, right? But that's why the neighborship is down. So I want to change that source IP. So what we need to do, we are using this command, but still the neighborship is down here.
So basically, it's like you're forcing the use the loopback interface, right? In this case, the IP address of the loopback interface.
Yes. Because I'm creating. See, because at the first time I'm saying remote neighbor, I'm creating a neighborship with my loopback IP, right?
Exactly.
With my loopback IP. That's why we need to say here loopback 1. If I create my neighborship using a physical interface IP and I want to change the source IP inside the packet, so I can like write here any like interface number as well. E0 by 0 or G0 by 0, loopback, any interface number. But I want to say here what? Because I'm creating a neighborship using the logical interface, or we can say that using the loopback interface. That's why I'm specify here loopback. Okay.
Understand. Okay. Perfect.
Okay.
Okay.
Yeah. So still the neighborship is down, but why the neighborship is down still?
Maybe it takes a while.
Check on R2. Okay, do one thing, guys. I told you I'm doing what? I'm doing static routing, right or wrong? I'm configure static routing on R1, R2, and R3, right? What happened here? On R1, we have 20 dot as well. I'm disabling everything here and on R2 as well. Oh, actually here I'm saying 2. No problem. I'm using any IGP protocol here. Don't worry. I'm not using static routing.
Because that's the R2, right? Yeah, R2. Okay.
Yes. So I'm using any IG protocol. So I'll say router EIGRP10 network 000. On R2, I'll say router EIGRP10 network 000. On R3, I'll say router EIGRP10 network 0.0.0. Wait for a second. If everything is fine, see, everything is fine. Now the BGP neighborship is also up.
Okay.
Okay. So it means what? It means if you are creating IBGP indirect neighborship using loopback interface, so we need to use one extra command, that is what?
The neighbor update source loopback.
And the command name is what we can say?
Update.
It's to update the
source.
IP
Loopback
source
1. This is the command, right?
Okay.
Okay. Exactly same in case of, we'll discuss now what? eBGP indirect neighborship using what? Loopback IP. Or we can say loopback interface. Here also the same requirement is there. First of all, so let's go. Yes. So let's go on R1. First of all, disable.
So we need to create a loopback again, right?
Yes. Let's go on R1 and let's disable the IG protocol as well. Let's go on R1 now and then say what? Router BGP say 100 and then what? And then say neighbor. My neighbor is what? 3.3.3.3. And then say the remote AS is what?
200.
300. Yeah. And on R3, I'll say what? Router BGP say 300. And then say the neighbor is what? 1.1.1.1. Remote AS will be what? 100. Correct?
100.
Done. The neighborship is down. Now what we need to do here?
Make the command update.
The update source loopback.
Yes, tell me guys, what we need to do now here?
Okay, we need to configure the
loopback interface.
Exactly. By neighbor.
Update source loopback. You already add the loopback IP you already add the loopback interface, right, with the IP address?
1.1.1 update source.
So I can use this command here as well. And here as well, according to you, you told me. Still the neighborship is down now.
Well, you already created the loopback interface or not?
Yes, he did.
Oh, okay, I need to check. I'll show you.
Oh well.
Yes.
He did.
Here it is available.
So do we have to do a static route here as well?
Okay.
RGB.
So can we use the any IG protocol?
Yes, or OSPF or EIGRP.
So let's use EIGRP because it is easy for me. Router EIGRP10 network 000, and we can use this on here as well. Router EIGRP 10 network.
What does it mean when you add the network 0000? What does it mean?
Okay, it means it will be advertise all the interface in the EIGRP.
Okay.
Yeah.
Okay, is it up or still? So you need to configure the IGP routing protocols in all the routers, right?
Yes.
In each router.
For the reachability.
Okay.
Yes, on each router, because I want to share the routes. Okay. Now I'll show you. Still, the BGP neighborship is down.
That went up, no?
Okay, I'll show you. No, it is not up.
Oh, is that up?
To show IP BGP summary.
I think I saw the message. Oh, idled.
Yes, on R3, I'll show you. BGP.
Oh, we need to do the
summary.
Do we? Oh, I think we need to do the TTL also, right?
I don't know.
I think so. Yeah, we need to update the value of the TTL.
I'll show you all the commands on both the routers. Then just to check and tell me. Yes, these are the commands that I'm entering on R1. And these are the commands that I'm entering on R3.
So we need to add another hop, 3 hops, so it doesn't fail.
Doesn't drop.
Doesn't drop the TTL.
Okay, so where?
So you need to configure the eBGP multi-hop neighbor.
Okay, on R1 or R3, where we need to configure on R1 or R3?
On both. On
okay.
both. You need to configure
so it
first
means
in
you
R1
told me
and then
neighbor 3.3. Sorry. Neighbor 3.3.3.3 eBGP multi-hop. That is 3, right?
3. Yes.
3 is fine.
Okay.
And do it on the other one too.
On R3, we need to say router BGP 300, and then say what neighbor 1.1.1.1, and then say eBGP multi-hop 3, right? Yes, perfect. The neighborship is up, right?
There we go. Boom.
That's good. Because sometimes you see this is the very important things. Why? Because in the real network, this is the problem happening actually. Okay. Sometimes what happen, the neighborship is down. It will be show you the active. It will be show the state will be active. It will be show a state will be idle state. So you need to know as a network engineer, as a senior network engineer, you need to know how to update neighborship. What are the problems? What are the command that we are using? So these that's it. These are the all problems here. Okay, that I told you here in the left side. Well, so these are the all commands.
Okay, in this case, the eBGP command with the multi-hop, we have to use it when it's in an indirect router, right? Right?
Yes.
Because if you are directly connected, there's no reason why to add this command.
No need, because you know, in eBGP we have a 1 TTL value, and if we have a direct neighborship, if we have the direct neighborship, and here the TTL value will be 1. Yes, then it will be reach here.
Exactly. So this command we only have to use it once there is like a router in the middle or something in the middle.
Yes, that's fine. Yes,
or a couple of routers. Maybe it's more than one. Maybe 10 routers. I don't know. It depends.
Yes, it means if you are making indirect neighborship, right? Indirect neighborship in eBGP, then we need to use this eBGP multi-hop command to increase the TTL values, right?
Exactly.
Yeah.
Okie dokes.
So.
Okay. Everything is good to you?
Yep. So far so good.
Actually, guys, this neighborship is very important in the BGP. Very important.
Okay.
Now the concept is clear, like which command we are using in eBGP, which command we are using in IBGP, direct, indirect. This command is fine. But my question is what? My question is what? Like normally we are using what? IBGP, direct, neighborship, correct?
Mm-hmm.
So why we need to configure indirect neighborship using loopback or using physical interface? Why?
You mean the
If
why we
someone
need to configure?
asks a question like you are saying in BGP we have three types of neighborship in IBGP, like IBGP direct neighborship, IBGP indirect neighborship using physical interface, IBGP indirect neighborship using using loopback interface. But if someone asks a question, why we are configure this, what are the like advantage, what are the profit when we configure this? So what you can tell us? Yeah.
Well, the loopback, the thing is that it's not a physical, because it's not a physical interface. If something happens with the physical interface, the loopback interface is always up. So let's say that something that the interface fell.
That's great.
For some reason. So maybe we'll have like a flapping or something. Something will happen.
Yes, this is the one of the best point here. So that's why this BGP will support indirect neighborship using the loopback. Whenever the physical interface goes down, still the neighborship is up.
And you know what?
Most of
the interface that I saw, like in every router, most of the people use loopback interfaces because it's more stable, I believe.
Yes. And how? And I'll show you here. Okay, I'll show you everything. Give me a second. I'll make a topology and I'll show you all the parameters here. Okay, each and everything in very depth. See. So first of all, I'll copy paste these all the points because these are the very, very, very important points. Where is my notepad? Yeah. Oh, what happened?
So loopback is more reliable.
Yes. Why it is reliable? I can explain you here. Okay. Okay, I'll make two topologies here, right? So okay, so here we have these three routers. So first of all, what I can do, I'll disable the BGP and everything on these routers. No router BGP. No router EIGRP. EIGRP 10. And on R2 as well. No router BGP. Say 100. And then say no router EIGRP 10. And let's go on R3. And then say what? No router BGP. Say 100. And then say what? 200. And then say no router EIGRP 10, right? So this is the normal topology we have. Do show IP interface brief. We have a one loopback on R1, okay? And on R3 as well, we have one loopback. Do show IP interface brief. Okay, that is fine. I'll make one more topology here for you. .2, right? And give me a second. Okay. And those both router having a loopback IP are for having 4.4.4.4/32, R7 having 7.7.7.7/32. Okay, so this is the topology. Now I'll start this devices and let's configure the IP first of all one by one. Let's go on R4. Just to say 0 and then say no shut. Interface F1 by 0. I'll say 30.1, 255, 255, 255.0, and then say no shut. No shut and then exit. And then we have a loopback as well. Okay. Now on R4, do show IP interface brief. So yes, these are the two loop physical interface IP and this is the one logical interface IP. Let's go on R5. F0 by 0. And then say 10.2. Here I'm configuring 20.1, 255, 255, 255.0. And then say what? No shut. Do show IP interface brief. I'll show you on R5. Okay, that is fine. Let's configure the IP address on R7 as well. On R7, we have two interfaces. 192.168.20.2, 255, 255, 255.0, and then say no shut. Interface F1 by 0. I'm having what? 40.1.255.255.255.0, and then say what, no shut, and one loopback as well. 777. Now I'll also show you here. So this is the logical interface IP, and these are the two physical interface IP. Now let's configure on R6 as well. Okay, so on R6 interface F0 by 0, 190.168, 30.2.255.255.255.0, and then say no shut. Interface F1 by 0. IP address is what? 40.2.255.255.255.0, and then say what? No shut. Done. Guys, IP address is configured. Correct. So now I'll show you first of all. I'm configuring here what? In direct neighborship, indirect neighborship using physical interface first. Okay, done. On both